Yes. In medium transmission line, as we discussed, in medium transmission line, there are three types of model. One is N-condenser method, the nominal T, nominal pi model. In N-condenser method, there's R, L, C parameters, resistance, inductance, and capacitance. The entire capacitance are concentrated at the end of the transmission line. So that's why you can see the diagram: resistance, inductance, and capacitance. So in that, the voltage regulation, that is VR is the receiving voltage. For this case, if you draw the phasor diagram, if you see that VR is taken as reference, there are two drops here, two current I can say. There are sending in current, another one is the capacitance current. The receiving in current plus capacitance current is together called as the sending in current. You can see that from the reference VR, the voltage is, the current is lagged by an angle of pi r, and if you add these two, the capacitance current is exactly 90 degrees from that. So if you add IR plus IC, it is coming together as sending in current IS. So if you add these two vectorially, VR plus IS into Z, that is a total voltage drop in the system, and total drop in the system. The corresponding sending in voltage is VS. VS is this corresponding sending in voltage. Then, by deriving all these equations, here also we have to find what is the receiving in power and sending in power to find the efficiency and regulations in the N-condenser model. The next one is the nominal T model or nominal T method. In this nominal T method, as I said earlier, the shape of this equivalent circuit is looking like T, English letter T. That is why it is called as T, nominal T method. Here, the entire resistance and capacitance is divided to equal half, and then one at the sending end, other one at the receiving end. You can see the equivalent circuit: R by 2, XL by 2 at the sending end, and R by 2, XL by 2 at the receiving end. There is a capacitor at the middle portion that is there. And if you send a voltage of Vs, there is a receiving end voltage Vr, and across the capacitance there is a voltage V1. Like this it will be. And for this we need to write the voltage and current relations. And while writing that, first write the V1 in terms of Vr. V1 is the mid voltage. Find V1 in terms of Vr. Then V1 in terms of Vs you have to find it. And the current relation is 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 equal to, as usual as previous case, Is is equal to IR plus IC1. Yes. This is the vectorial diagram or phasor diagram to represent all the relations between the sending in voltage, receiving in voltage, etc. And you can see that. And from there, you have to write the current and voltage relations. Then find the V1 value. By knowing the V1 value, you have to find the capacitive current. Then find the regulation and efficiency of that. Then these are the formulas which are related to, these are the numericals which you have to solve based on the three modeling. There is N-condenser and nominal T. And coming to nominal pi model, in nominal pi model, as I said earlier, in nominal pi model, the transmission line or equivalent circuit, if you see that, it is looking like a pi shape. The entire capacitance, the resistance and capacitance are at the middle. That means entire resistance and inductance are lumped parameter. The total capacitance is divided to two half, one at the sending end, other one at the receiving end. And if you see that Vs is the sending in voltage across the capacitance, the half of the capacitance, other capacitance across that is the VR. Then here also for doing the phasor diagram, VR is taken as reference, similar to the previous two cases. VR is taken as reference. Then the corresponding, there are IR current, IC1, IC2. There are IR is the receiving end current. There are two capacitances are there, two shunt branches. IC1, IC2 current you have to find it. Then from that you have to draw the value of IS, that is the sending end current. From there you have to come out VR plus IL into R plus IL into XL will give you the sending in voltage Vs. That is a model based on the nominal pi model. This is the once again numericals based on that. I don't want to go to the details about the numericals, we will go to the theory behind this. Then coming to the long transmission line. So far we discussed about short transmission line, medium transmission line, and long medium transmission line. In medium transmission line itself, we have three models we discussed: N-condenser method, nominal T model, and nominal pi model. Then coming to the long transmission line, in long transmission line, as a real-time system, the resistance, inductance, and capacitance are divided into equal half, that is distributed in nature. That means if it is n kilometer, then the resistance is divided into n equal halves, R by n, like that we can say. And the total inductive reactance is also divided into XL by n, similarly capacitor. So this long transmission line is solved by rigorous method. Here, if you see the equivalent circuit of that, R by n and XL by n are the corresponding resistance of each section. There are n sections are there, and the corresponding Y, that means admittance is classified into B and G. We know that B is the susceptance, G is the conductance. So that is also modeled here. Vs is the sending in voltage, Vr is the receiving in voltage. Here the thing is all the parameters, resistance, inductance and capacitance of the lines are distributed in nature, so that whatever the value which you got from this rigorous method is accurate as that of your practical calculation. So to do that, we consider that there is a small portion dx in the entire transmission line of n kilometer. We consider that there is a small portion dx, where for this small portion dx, the small impedance is zx, you can see that, and small admittance is ydx. Okay, and in front of this section, if we see, V plus Vb is the voltage, that means before the section. After the section, the voltage is V, and the current entering towards the section is I plus Di. Current leaving the section is I. Like that you have said. Okay, and the drop in the section is what? Then dA is the current drop. dA is the total drop which is there, and dV is the corresponding voltage drop which is there in the system. We are assuming this. If we solve the corresponding wave Z, Y, B, these are the series impedance. V plus dV is the voltage at the in front of the system, and I plus D is the current entry. I is the current leaving the element. If you do all those things, we come across the equations, and then we found that there are two equations, one for voltage, other one is for the current, and at x is equal to 0. If x is equal to 0 means x is the distance between from the receiving end. So if x is equal to 0, then V equal to VR and I is equal to IR. That means we are in the receiving end. If x is equal to L, then V equal to Vs and I equal to Is. Like that, we have to substitute and find the corresponding equation for V and I. V is the voltage. The receiving end, if you want to substitute x is equal to 0. If you want the sending in parameter, then substitute x is equal to L and find that. Then after finding all those things, the final expression of sending in voltage and sending in currents are Vs is equal to Vr cos h root x y z, IR into root of z by y into sin x root y z. Similarly, Is also you have to find it. So this is the final expression for the sending.